Okay, next one is thermodynamic identity. Now, if suppose I have a system, suppose I have to go from state 1 to state 2. And in order to go from about state 1 to state 2, my energy changes by the amount delta U, and my volume changes from the amount with the amount delta V. And I want to answer this question. What is the entropy change during this process? Transformation? I want to use the word transformation here. Remember we said transformation and processes can be used interchangeably? And because there's two major changes that are happening in my system, can I call those two changes step 1 and step 2? Then may I write the total entropy change as delta S1 plus delta S2? So this is step 1, and this is step 2. Okay, so for step 1, may I do this? Am I allowed to do that? So since these are small changes, may I write these as partials? Partial S over partial U, delta U. Actually, I'm going to call them small. For small changes, it'll be du. Plus partial S over partial V, delta V. Okay, so for step 1, constant volume, may I write delta S as Q over T? And for constant volume, so constant volume implies W is 0. May I rewrite this as du over T? Or partial S over partial U equals 1 over T? Everybody following along? Okay. So step 2, constant T implies du is 0. So then may I write delta S equals Q over T equals minus W over T? With me so far? This is from the first law, right? Casey, you got that? Or do you want me to explain it? Oh, yay. Or may I write this as PdV over T? I can do that, right? So then may I rewrite this as partial S over partial V equals P over T?
Yes, but actually,
yes.
I think it was a clarifier.
Me?
Yes, it's okay. Small changes, you wrote du plus delta V.
Where?
Delta S equals
Q
partial,
over.
yeah, should not be dV, not delta V. Du.
Oh, yes, you're right. This should be D. You're right. It will be for small changes. Guys, did everybody get that? I put a delta, but it's for small changes. It should be D. Good catch. Okay, so far so good. Make sense? Now, may I rewrite this equation A and B? Can I plug them into equation? What do we want to call this equation?
Yeah, do a giraffe.
I can't do giraffes.
Try to say stick.
Okay.
Stick. Caterpillar.
Yes. Yes. Yes.
Yes.
Frog.
Yes.
Yeah.
And a little tail. Little tail.
And a little tail.
You make
Giraffe.
a meat leaf.
What?
You make a meat leaf.
A tree. A is the tree equation. B is the giraffe.
We will do trees next time.
Fine.
So the giraffe will eat, the last equation will be the tree because the giraffe wants to get to the tree. How's that?
Got that right.
Yeah. Oh, okay. Stop making me draw those things. Okay. So we're plugging the values back in here.
Giraffes, Dr. Say.
So for my giraffe equation, may I rewrite this as 1 over T du plus P over T dv? Or T ds equals du plus P dv. And for and this is called the tree equation.
That's a pretty good tree.
Are you sure?
Yeah.
Okay, I'll put green in it.
It's a little broccoli-y, but it's a good tree.
Yeah, because the giraffe wants to get to the tree. And the tree equation is now what is known as the thermodynamical identity. It is one of the most important equations that you will have.
Great.
And it's a tree. So remember the tree equation. This is called the thermodynamical identity. And if you were just given this equation, it looks scary, doesn't it?
A little.
But since you have seen the progression, did I do anything fancy?
No.
Anything new? Nothing.
You did math.
I did math. Okay, so from my thermodynamical identity, I can write for a couple of processes. So which ones should I pick? I think I'm just going to do constant pressure, and I'm going to do constant temperature. So for two of them. For constant, no, actually, I'm going to do constant volume. My bad. Let's do constant volume. So constant volume pressure means dV equals 0. Constant temperature means delta T equals 0, which from first law means delta U equals 0. What will my tree equation reduce to? That's you. For part 1, will my T equation become du equals TdS or T equals du over ds? And for this one, will my tree equation become 0 equals TdS minus PdV or P equals TdS divided by dV? If you were to just see these equations, they look very scary, but they're actually not.